Okay, so today we're going to talk about arithmetic sequences. So put that at the top of your page with today's date. Now a sequence is basically just a list of numbers. You don't have to write this part down, but a sequence could be, it's kind of what we're going over in class, the outputs. It's 7, 14, 21, 28, and so on, okay? So that is what a sequence is. So what we're going to do is take those sequences and make them into equations. So a couple definitions first. First definition is sequence. It is an ordered list of numbers or objects. An ordered list of numbers or objects. Ordered is important because they actually follow an order. So that could be something as simple as 2, 4, 6, 8, and so on. That is a sequence. Now, this is interesting. A term. A term is an element or number in a sequence. So like this is your first term, second term, third term, fourth term. So it's important to know that. And the first one's always the first term. It just lists starting in order, starting from the beginning. Now, what we're dealing with today are arithmetic sequences. And that is a sequence in which the difference between consecutive terms is always the same. So that means that whatever is between those two numbers is always the same. For example, 7, 10, 13, 16. It follows a pattern of plus 3, meaning, and it says a sequence in which difference between consecutive terms. Consecutive terms meaning in a row, so terms in a row, are going up by the same. They're going up by 3 or going down by the same. That's fine too. So I want you to write down this sequence, 7, 10, 13, 16, and then this little ellipsis says that it goes on forever. And I want you to write down underneath it, above it, I want you to write down 1, 2, 3, 4. And then I want you to write down that these are the term numbers. Term numbers. Like 7 is term 1, 10 is term 2, 13 is term 3, 16 is term 4. The only difference between this and the tables we were using before is these are all outputs, and we're putting in the inputs. And they always start in order. Always start with 1. So this sequence can actually be rewritten like this. I could say these are my x's and y's, and this would be 1, 7, 2, 10, 3, 13, 4, 16, and if we had a 5, it would be 19. Okay? So now we're going to take these, and just like we've been doing before, turn them into functions or equations, whatever you want to call it. So now we have to find the function that describes this sequence. So here we have 2, 4, 6, 8. And I'm going to put my term number in. So you should be writing this down, 2, 4, 6, 8, with the ... And this is term 1, term 2, term 3, and term 4. Now I could make a table if I wanted, right? X's and Y's. It's kind of made right there for us, right? Term 1, term 2, term 3, term 4. And that'd be 2, 4, 6, 8. We don't necessarily need to do that because we can just look over here. This is going up by 2, right? So it's y equals 2x because it's going up by 2. That's the pattern. Now, what's the 0 term? If this is the first term, what comes before it? Well, before it, if it's going up by 2 this way, it's going down by 2 this way. So my 0 term is actually 0. So you could say y equals 2x plus 0. Or you could just say y equals 2x. Don't need the plus 0 because it really doesn't make a difference. Let's look at this one down here, number 2. We have 11, 17, 23, 29. So these, that's my first term, second term, third term, fourth term. These are going up by 6. So it's going to be y equals 6x. Now what do we add on to it? Well, if this is my first term, my 0 term would be before it, and going backwards, minus 6 would be a 5. So it would be 6x plus 5. Try numbers 3 and 4 on your own. Okay, welcome back. So this goes 4, 8, 12, 16. First term, second term, third term, fourth term. So it's going up by 4, right? So it's y equals 4x. If that's the first term, this is a 0 term, right? If it's going up by 4 that way, down by 4 this way, so that's 0. So it'll be y equals 4x plus 0, or just y equals 4x. And over here, these are going down by 2. You may think they're going up by 2, but they're not. They're getting more negative, so that's actually a minus 2. So it'd be y equals negative 2x, because it's going down by 2. And then if this is first term, second term, third term, fourth term, what would my 0 term be? Well, if you just follow the pattern, it would be negative 4. So it's negative 2x plus negative 4. Now you could also say, this works too, you could also say y equals negative 2x minus 4, because plus negative here and minus are the same thing. Okay. Now we have word problems. And this may look intimidating. It's not intimidating. Let's just break it down. You do not have to write down this whole word problem. Don't write the whole thing down. But it says, a school choir is taking a trip to a water park. The choir must pay a transportation fee of $100 plus $17.75 for each student to enter the park. Find a function that describes the arithmetic sequence. Then find the total cost for a group of 23 students to enter the park. Now, let's reread it. We read it once, reread it. A school choir is taking a trip to a water park. The choir must pay a transportation fee of $100 plus, we already see something in our equation right there, right? $17.75 for each student. When we see this word each, we know that's multiplication. And think about this. If it's one student, it's $17.75. If it's two students, multiply it by 2. Because they're tickets, right? They're like you're paying to get in. Plus the transportation fee. That's a one-time fee. You're not paying that every single time. It says find a function that describes the arithmetic sequence. So it's y equals something times x plus something, right? Now it says $100 plus $17.75 for each student. When we see that word each, that's multiplication. So it's going to be 17.75x, because it's multiplication, right? Each student pays that much, and we don't know how many students, plus the one-time fee. It just says a transportation fee of $100, no matter how many students. It doesn't say no matter how many students, but no matter how many students. Now it says, then find the total cost of a group of 23 students. This is X students. This is if we had 100 students, 1,000 students, 1 student, 2 students. So we need to find out for 23 students. So we would just plug in 17.75 times 23 plus 100. And so now we have to do a little multiplication over here to the side. So that's a 5, 1, 22, carry the 2, 23, 0 placeholder. That's a 10, carry the 1, 15, carry the 1, 15, carry the 1, and that'd be a 3. Okay. All right, so now we add them together. And we put the decimal back in, right? There's 2 digits after the decimal, so there have to be 2 digits here after the decimal. So now you have 408.25 plus 100. And we add those together, and we would get 508.25. Now that's my number, but that's not my answer, right? I have to put in the total cost for the group is the total cost for a group of 23 students is 508.25. And that's $508.25. All right. So remember, the word each, we're multiplying, right? And just think about it in real terms, real life situations. Try number 6 on your own. Okay, welcome back. It says a DVD costs $3.95 to rent plus again, 0.45 or 45 cents for each day it is returned late. Again, that word each. Find a function that describes the arithmetic sequence and then find the total cost of renting the DVD and returning it 9 days late. So it's $3.95 to rent. That's like a one-time deal. $3.95 no matter what. Plus, and it tells you, plus 45 cents for each day. 0.45 times x, because it's multiplication each day. Now you might have, and this is fine, something times x plus something. You might have 0.45x plus $3.95. You might have that, and that's fine. They're the same thing. Now we have to figure out when it's 9 days late. So this is x days. We need to figure out for 9 days. So we're going to do 0.45 times 9 plus $3.95. So we do 45 times 9. And that's a 0.45, so 2 digits after the decimal, so it'd be like this, $4.05. So we have $4.05 plus $3.95, and that's $8. So you would say the total cost is $8. All right. Great job. See you later.